So today we're going to continue to look at graphing equations. And so your focus for today is I can develop fluency with graphing equations by using input-output tables and equations. And we're going to really be looking today, if you look right here at this learning target, looking at using operations or using equations that have more than one operation. So if we take a look at this solve and share, it says Greg registered to be in a walkathon for his grandmother's charity. His grandmother said that she will contribute $1 for his participation and $2 for each mile that he walks. Graph the equation C equals 2m plus 1 on a coordinate plane, where C is the contribution his grandmother will make, and m is the number of miles that Greg walks. So what's nice here is they gave us the equation that we're going to use. We don't have to try and build it ourselves. They gave it to us. C equals 2m plus 1. M is the miles that Greg walks, and C is how much grandmother is going to give. So it's a two-step equation, so you may need to show your thought process and do a little bit of work onto the side to get it. So I'm going to go through and I'm going to do 2m. So 2 times 1 is 2, plus 1 is going to be 3. So when m is 1, c is 3. Okay. My next one, 2 times 2 is going to be 4, plus 1 is going to be 5. So when m is 2, c is 5. And then the last one is going to be 3 times 2, which is 6, plus 1 is going to be 7. Okay. And so just again, substitution is what I did there. I substituted for m to find c. Now I have ordered pairs. So this is an ordered pair right here. 2 of 5 is an ordered pair. 3, 7 is an ordered pair. Okay. So on my graph, you'll notice that my axes are labeled. This is M right here. This is C right here. So this tells me that this is going to be my vertical coordinates. This is going to be my horizontal coordinates. So I'm going to go ahead and I'm going to plot my points. So my first one that I have is 1, 3. So I'm going to go over here to 1, 3, mark it. Next one is going to be 2, 5. I'm going to go ahead and mark that. My last one is going to be 3, 7. So I'm going to go ahead and get that marked. And then we're going to build that linear graph. And remember, when we build that linear graph, we need to make sure that we get our values lined up and we extend the line all the way out so that way we can find future values. And so I'm actually going to go just a little further on both sides to see, and then we can look at that. So I can use this information to help me graph the value. So if I take a look at the look back, it says use your graph to find how many miles Greg must walk if he wants to raise $11. So we talked about this yesterday, that we go to the value 11. So I find the value 11 and I go over to where the line crosses the graph. And so here it's not exact. It's probably more of my line making than anything else. This is why it's important. So I'm going to go to this point and then I'm going to go down and my value is going to be 6. Oh, that's up. Let me go back up to 11. Let me remake my line and see if I can make it to where it works a little bit better, because it should be crossing at an exact value and it was not. So give me a second to remake my line and then we'll go back through and graph. Go back and we'll take a look at that. That is a little bit better. It hits more of the points better. So I'm going to go over to 11. I'm going to come back over. I'm going to see where it hits. It hits at this point right here. So I'm going to go ahead. I'm going to mark that. And then it goes right here. So in order for him to raise $11, he needs to walk 5 miles. So another way that I can check this, so let me do this. Another way that I can check this is to actually go into the equation and substitute to see if my point is going to be correct. So we said that it's going to be 511. So I'm going to put 5 into the equation, the C equals 2m plus 1, and go from there. So if I have 5 times 2, that's going to be 10, plus 1 is going to be 11. That equation works. That is the point that is on that graph. Okay, so let's go ahead and head into the next page and take a look at the next one. So the temperature was 6 degrees Celsius and increased 2 degrees Celsius each hour for 6 hours. So X is the number of hours, Y is the temperature in C degrees, and then here's my equation. So the first thing that we're going to do is we're going to make a table, and we're going to find a value for right here, after how many hours was the temperature 12 degrees Celsius. Equals 6 plus 2x shows the relationship between the number of hours and the increase in temperature. After how many hours was the temperature 12 degrees Celsius? Okay, so we're going to make a table. So here's the equation that we have, which is nice that they gave us that equation. So the equation that we have is y equals 6 plus 2x. So if x is 0, I am going to make, it's going to be 6 because 2 times 0 is 0 plus 6 is 6. So you'll notice here that they didn't give us 12 degrees Celsius because that's what we're trying to find. But we just picked values. So they just picked 0, 2, and 4 to find the values for the temperature. So when it's 0, the temperature is going to be 6. When it's 2, the temperature is going to be 10. And when it's 4, the temperature is going to be 14 degrees. Okay, so after 4 hours, it's going to be 14 degrees. So then you're going to plot, and you'll notice that this line is extended all the way through, and it is in the negatives because we do have the possibility of negatives because temperature can be a negative value. And so we've plotted 0, 6, 2, 10, and then 4, 14. And so what we're looking for is we're looking for that 12. And so what you're going to do is you're going to go to the 12 degrees Celsius because, again, y was representing Celsius. And I'm going to go over to see where that intersects on the line. And then I'm going to come down, and where it is, it's at 0.3. So my point is going to be 312. And again, one of the nice things I can do is I can check that point by plugging it into the equation to see that it is correct. So if I plug it into the equation where I have x is 3 and then I had 12. So I'm going to just check and see if that point is going to be on this line, y equals 6 plus 2x. So I'm going to say that I have 12 equals 6 plus 2x. All right, so this side's going to stay the same. Nothing's going to change because 12 is 12. That's my total. And then this is going to be 6 plus 6 because I did 2 times 3. This really should have been a 3 up here. And then I have 12 equals 12. So that point is on the line for y equals 6 plus 2x. So I can always substitute in and check to see that the point I found is really a point on that line. Okay, so let's go ahead and take a look at your convince me. It says, suppose it was noon when the temperature was 6 degrees Celsius. What time would it be when the temperature reached 12 degrees? So we had the point of 312. So this represents the number of hours. So 3 is going to be the number of hours that pass. So if it was noon, 3 hours would be 3 o'clock p.m. because 1 o'clock is 1 hour, 2 o'clock is 2 hours, 3 o'clock is 3 hours. So it'll be 3 o'clock p.m. All right, let's head to your guided practice. So if we take a look at your guided practice, the first question says, is the point 1026 on the line of the equation y equals 6 plus 2x? So explain. So the first thing we need to do is we need to check to see if it's on there. So I'm going to go ahead and I'm going to show my work. I have both values, so I need to substitute for both values. So I'm going to have 26 equals 6 added to 2 times 10. Again, I don't do anything with the 26, but because they gave me the value, I need to include it. So I'm not just doing this side of the equation. I really have to substitute for both sides of the equations. So then I have 6 plus 20, and then 26 is equal to 26. So it is on the line. So yes, it's on the line because when I substituted 10 in for x, I got a value of 26. So when I substituted 10 in for x and then solved the equation, I got a value of 26. Okay, number 2. So suppose the temperature is 6 degrees Celsius and decreases half a degree Celsius each hour. What equation could you use to graph this relationship if h is the number of hours and t is the temperature? So t is my temperature. That's my dependent variable because my hours is going to change the temperature. So t is going to be on one side of the equation, and then my independent variable is going to be that half a degree increase each hour. So if the temperature starts at 6 degrees and it decreases, I'm going to be subtracting. And then 5 degrees Celsius each hour, I'm decreasing by the same amount each hour. When I do something the same amount each time, that tells me I'm doing multiplication. So it's going to be 0.5 H, because H represents hour. So this is a coefficient relationship. So this is the equation that I could use to determine what the temperature would be after H hours. All right, number 3, complete the table and graph of D equals 5 plus 5T. So T is my independent variable, D is my dependent variable. So if T is 0, so I'm going to do 5 times 0, which is 0, plus 5. So here I get 5, okay? And I'm going to do my next one. 2 times 5 is going to be 10, plus 5 is going to be 15. And I need to do one more value. It doesn't make sense for me to go past the value of 4 because my graph only goes to 4. So I'm just going to go ahead and I'm going to keep it at 3. Keep my numbers small and tight. So 3 times 5 is 15, plus 5 is going to be 20. All right. So I'm going to graph my points. So I have 0, 5. And then I have 2, 15. So 2, 15. I make sure I'm going to graph them. And then 3, 20. Go ahead and draw my line. And my line, I want to make sure that I connect all the points through. And then extend my line out. And then that's it. That's how I represent that one. Okay. And if I needed to, if I wanted to know how far I went when I had a T for time, I could do that simply by looking at the values on the line. Independent practice and your mathematical practices and problem solving, making sure that you're reading each question carefully and doing what it's asking you to do. Sometimes it may ask you to graph an equation. Sometimes it may ask you to check using an equation or finding a point on